Have you ever pondered what would happen if a massive solar flare hit Earth? It's a question that inspires both awe and fear, a testament to the power and mystery of our universe. Solar flares, in essence, are enormous explosions on the sun, releasing energy equivalent to millions of hydrogen bombs. They're born from the sun's magnetic field, which can get twisted and stretched like an elastic band. When the tension is too much to bear, it snaps, releasing energy in a brilliant, fiery display. These solar flares are categorized based on their strength. The smallest ones, Class A, are virtually harmless. But then we have the real beasts, the X-class flares, which can cause wide-scale disruption and damage. Remember the year 2017? That's when the sun last unleashed an X-class flare, a raging monster of solar energy. Fast forward to now, and we're witnessing the largest solar flare since that event. It's a spectacle of interstellar proportions, a cosmic ballet that has scientists across the globe riveted. But what does this mean for us here on Earth? Well, that's where things get really interesting. You see, solar flares are not just beautiful to observe. They carry a payload of charged particles that can travel all the way to our planet. When they reach us, they can play havoc with our technology, degrading radio signals and even knocking out power grids. But it's not all doom and gloom. These solar flares also give us a chance to marvel at one of nature's most awe-inspiring spectacles, the auroras. These ethereal lights are a direct result of solar flares, a silent symphony of color playing out in the skies above us. So, as we stand on the brink of increased solar activity, it's time to strap in and prepare for a celestial show like no other. The sun, it seems, has a few tricks up its sleeve, and we're all invited to the performance. Now, let's delve into the fascinating journey of a solar flare, from its detection to its potential impacts. Detection of solar flares starts with vigilant monitoring of the sun's activity. This is a round-the-clock operation, as our fiery celestial neighbor is constantly active, and these flares can happen without warning. So, how do we keep our eyes on the sun without literally frying our retinas? Thank goodness for technology. First off, let's talk about the impressive spacecraft in our arsenal. Take the Solar Orbiter, for example. This is a joint mission by NASA and the European Space Agency, and its job is to study the sun up close and personal. One of the things it looks out for is tiny flares shooting from holes in the sun, also known as picoflares. These picoflares are a few hundred kilometers long and emit as much energy as 3,000 to 4,000 US households consume in a year. Despite their size, these picoflares can be key sources of the solar wind, which in turn can affect our very own planet Earth. But it's not just spacecraft that we rely on. Ground-based telescopes also play a crucial role in detecting solar flares. These telescopes, equipped with state-of-the-art instruments, observe changes in the sun's activity and help scientists predict potential solar flares. One such instrument is a spectrometer, which measures the light spectrum and helps identify the physical properties of the flare, such as temperature, density, and speed. We also keep an eye on sunspots, cooler areas on the sun's surface that form in regions with strong magnetic fields. More sunspots indicate increased magnetic activity, which can lead to powerful solar flares. In fact, in June, scientists observed the highest number of sunspots in over 2 decades. So, with all these tools and techniques at our disposal, we're able to stay one step ahead of solar flares. Once detected, the clock starts ticking as we prepare for the potential impacts of the solar flare. A solar flare's journey from the sun to Earth is both swift and tumultuous. Imagine the sun, a fiery ball of gas and plasma, constantly churning and twisting with magnetic energy. In an instant, a solar flare, a burst of light and energy, explodes from its surface. Its journey has begun. This flare, a veritable cosmic bullet, races through the vacuum of space at speeds reaching up to 1,000,000 miles per hour. Yes, you heard it right, 1,000,000 miles per hour. It's like New York to Beijing in less than 2 minutes. Now that's a speed to marvel at. As it hurtles through space, The solar flare carries with it a shower of charged particles. This is the solar wind, a stream of electrically charged particles that constantly blows from the sun. It's this solar wind that propels the solar flare on its journey towards Earth. Picture the solar wind as an invisible cosmic conveyor belt, carrying the flare across the vastness of space. But what are these charged particles, you might ask? Well, they're primarily composed of electrons, protons, and heavier atomic nuclei. These particles, although tiny, carry immense energy and are the main drivers behind some of the most mesmerizing and potentially disruptive phenomena we experience here on Earth. This journey from the Sun to our home planet takes about 8 minutes. It's an incredibly short time considering the sheer distance covered, a testament to the immense speed at which these solar flares travel. But the journey of a solar flare is not just about speed, it's a cosmic ballet, a dance of energy and particles played out across the stage of our solar system. It's a spectacle of nature that highlights the raw, untamed power of our sun and its influence on the space surrounding it. Upon reaching Earth, the solar flare's impact can range from awe-inspiring to potentially disruptive. But more on that in the next scene. For now, let's just marvel at the journey of these solar behemoths, these cosmic bullets that race across space, bringing with them a piece of our sun. Solar flares have a profound influence on Earth, influencing both natural phenomena and human technology. Their effects are far-reaching and varied, from sparking the dazzling dance of the northern and southern lights to causing disruptions in our everyday tech. First off, let's talk auroras. These spectacular light shows are a direct result of solar flares. When charged particles from a solar flare collide with Earth's magnetic field, they can create these magnificent, shimmering curtains of light in the sky. The northern lights, also known as the aurora borealis and their southern counterpart, the aurora australis, are a breathtaking testament to the power of our sun. But not all effects of solar flares are as visually stunning. They can also cause disruptions in radio signals. When a powerful solar flare hits, it can degrade or even black out radio communications. This is particularly concerning for areas that rely heavily on radio for communication, such as remote regions and aviation industries. Beyond earthly concerns, solar flares can pose a significant threat to astronauts and satellites in space. The intense radiation from these flares can harm astronauts, potentially causing health risks. Satellites, too, can be affected. As our world grows more reliant on satellite technology for everything from GPS navigation to weather forecasting, the impact of solar flares on these vital tools becomes increasingly significant. And believe it or not, these flares can even cause power outages on Earth. The charged particles they emit can interfere with power grids, causing blackouts. In extreme cases, they could even damage transformers or other essential components of our power infrastructure. While our planet's magnetic field provides a protective shield, solar flares remind us of our vulnerability to cosmic events. From the beauty of auroras to the potential chaos of power outages and radio blackouts, the impacts of solar flares are a compelling reminder of our sun's powerful influence. So, as we continue to explore the vast expanse of space, let's also remember to keep an eye on our own star, for its activity holds profound implications for our world.